Okay, so this is a question for Carmen. Question like this is going to show up on Thursday's quiz, and I just repeated all of that so that if anybody watches the video, they get that information. Okay, f of x is 1 over x plus 14. Okay, so we write it as y equal, and then the idea is swap the x's and the y's. Okay, and that comes back to Lindsay's question. When it's a graph, it's easy. When it's a function, maybe not so easy. Okay, so now the trick was solve for the new y value. And this is kind of tricky. This is, in fact, it's way tricky. So I am going to cross multiply. That's my favorite thing. Put a 1 under here so I can cross multiply. So if I cross this way, I get 1 equals x times y plus 14. Okay, now the game is solve for the new y. Get the new y alone. I can see two ways of solving this, and I don't know which way I want to go with this, Carmen.
Both ways. No, I don't know.
Okay, I'll go both ways and see that. Okay, so the first most common one is to distribute the x in here. So we have 1 equals xy plus 14x. Okay, then I want to get the y alone. Keep that in mind. I'm always trying to get the y alone. So I'm going to get rid of the 14x. So that's 1 subtract 14x equals xy. Okay, now I still got to get the y alone, but it's being multiplied by the x. So I'm going to divide everybody by x. And that's going to give me 1 minus 14x over x equals, now technically it's y, but I said replace the y back with the inverse notation. Okay, or not okay? Now that may not be one of the answers. If I was asking this question, and you showed me that, you'd get full credit. If mom is asking this question, she may have a slightly different form. So I'm going to show you how to modify for mom. Maybe. I mean, if this is one of the answers, cool.
That actually worked.
Okay. Well, then do you want me to just stop or do you want me to continue?
I say might as well learn the other way.
Okay. Well, we know a couple things. We know that we can take this apart. So this will become 1 over x minus 14x over x. So this will become 1 over x minus 14 equals f inverse of x. So that's an alternate form for the same problem. Okay? But it's even worse than that. Where's my glare? It's right there. Suppose I was right at this step, well, here, and I cross multiplied, so I'm at this step right here. Okay.
Okay.
So where's my glare? 1 equals x times y plus 14. What if I divide both sides by x? Okay, that's going to give me 1 over x equals, I'm writing right into the glare. That's going to give me 1 over x equals y plus 14. because I got rid of the x, so there's no reason for parentheses any longer. Take away the 14, and I get 1 over x. Take away the 14 from both sides, equals, instead of y, we put f inverse, and look at this. Same answer. So the problem with this, and boy, I don't know if we're going to get to it tonight or we're going to hit it tomorrow, but solving this, as you guys get more and more sophisticated, there's more and more proper ways to solve for y. And I can't tell you what's the best proper way. I can just tell you what you needed to get to here or you needed to get to here. Okay, how you got there, there's a bunch of correct ways of getting there, but there is the answer.
Okay, yeah. When I saw it, I was like, I don't even know where to start for some reason.
Well, you could have divided by x, and that gets rid of the parentheses. See, the key was you can't get to the y because it's trapped inside those parentheses.
Mm-hmm.
Okay, so somehow or other, you've got to get rid of the parentheses. One way is to divide both sides by x, and that removes the need for the parentheses. The other way was distribute the x in, and that automatically cancels parentheses.
Well, I didn't even think of putting the 1 under the x, so I was stuck there.
Oh, okay. That you're gonna get in Math 104 a whole bunch of proportions or problems that can be turned into proportions by cheating a 1 underneath it.
Mm.
And it's so much simpler if you kind of work on that skill. So a lot of the problems, put a 1 and cross multiply, and man, they're going to work out really cool. Okay. All right. I do have to get on the new stuff, guys. But actually, I don't want to. All right. How many people are here? Almost everybody.
Professor Foster, why does under the test that says vote?
Ask me after this example.
Okay.
I want to give everybody else a chance to log in. Okay, and do this. All right. One of the things on the quiz that people botched was solve a quadratic inequality. So here is a really horrible here's a really horrible problem. And because a lot of you guys got the right answer for all the wrong reasons. You guessed, you tried to use logic on it, and you got the right answer on the quiz, but you got it for all the wrong reasons because I looked at your work. Okay. Oh, by the way, I should point out, chapter 7.6, everybody got full credit. I just went through, I didn't put it in MOM, I put it in my spreadsheet. Okay, so I download all your homework, create a spreadsheet to add up all your scores. And just in section 7.6, remember several of you were saying MOM was deleting your scores and stuff. I just gave everybody full credit for 7.6 in my spreadsheet, not on MOM itself. Okay, but you got full credit. So, and I'm writing people trying to figure out, nobody seems to have ever, that's never occurred to anybody yet. So we're still working on why it happened. But back to here. All right, do you guys want to take some time, try and solve this, or do you want me to walk you through it?
Walk through.
Okay, walk through. Walk is, never mind. Okay, so the first thing we're going to do is we're going to pretend that it's an equal, and we're going to try and not an equal. We're going to try and solve it. Okay, well, the first thing I see here is I can factor out an x. They all have x in common. So that leaves x squared minus 4x plus 4 equals 0. Okay, now I can factor that some more. So I have x times x minus 2 times x minus 2 equals 0. So while I'm going a little bit fast, okay, what I'm doing should be pretty, you should be pretty used to it now. Factored out what they had in common, then factored the trinomial. Now, technically, we're supposed to take this apart and say x equals 0, or x minus 2 equals 0, or x minus 2 equals 0. So that gives me x equals 0, 2, and that's also a 2, so it doesn't matter. Okay, we got x equals 2 and 2. Recall that these are called critical values. These are not the solutions. These are critical values. Okay, they're not the solutions. If this were an equal sign, if the original problem had an equal in it, these would be the solutions and we'd quit. Okay, if the original problem was an equal, we'd say, hey, there's our answers, we're done, yay. But it wasn't, it was an inequality. So we have to do more. Okay, and the more was called interval testing. And what we do is we put on a number line the critical values, 0 and 2. Then because it was equal, right here, because it was equal, we use solid dots. And this is what I didn't see people doing. I didn't see this number line. I saw some work. A lot of people, now I'm speaking in general terms. Many people, several people got it right, but many other people just had garbage or work that was inappropriate to the problem or to what I was looking for. So I'm showing you the correct way. Almost everybody got the correct critical values. Everybody got to here. But then what you did with them, okay, this is where we fell apart. This is where I was looking at your work. Okay, so we put the critical values on the number line and then we test points. Now, this particular one is a little bit harder, but okay, I'm going to test 3. Because remember, you're testing any number from 2 to infinity. This interval is from 2 to infinity. So we're picking a test number, anything you want. We always plug it back into the original problem. Okay, I don't care if I see your work or not. It doesn't matter to me. Okay, many of you showed me your work, which is great. Okay, but what you're doing here is you're saying, I'm going to take 3, I'm going to go 3 cubed minus 4 times 3 squared plus 4 times 3. Is it greater than or equal to 0? That's a question mark there. I don't know if you guys can read the red there. So we're taking 3, we're plugging it into the original problem, and I will tell you there is a shortcut that I don't choose. It's a minor shortcut that I don't choose to teach right now, okay, because we have enough trouble doing the thing right the first time. So our math says this is 27. 3 cubed is 27, minus 4 times 9 is 36, plus 12. Okay, 27 minus 36, okay, is, what's that, -9? Yeah, -9. That's -9 plus 12. That's +3. Is 3 greater than or equal to 0? True. And I wanted to see the words true up there. And that every single time I've done the problem, every single one of these, this is what I've done. I've picked a test number, plugged it into the original, and determined, did my test number give me a true or false statement? Is 3 greater than 0? True. Okay. Now, usually we can pick 0, but I manufactured this problem this way on purpose. We can't pick 0. We have to pick some number in between 0 and 2. Okay. Most of us would pick 1, but you know what, guys? You could pick 0.5. You could pick 1.5. You could pick any number you want as long as it's between 0 and 2. Now, again, the laziness of all of us says 1 would be the easiest. Okay, plug it back into the original. So we have in the original, we have 1 squared minus 4, 1 cubed, 1 to the 3rd power, minus 4 times 1 to the 2nd power, plus 4 times 1. Is it greater than or equal to 0? That's what we're checking out. Okay, so this is 1 minus 4, because 1 squared is 1 times 4 is minus 4, plus 4. 1 minus 4 plus 4 is 1. Is 1 greater than 0? True. Holy crud. It's a true. Okay, we do it again. Pick a number from 0 to -infinity. Again, most of us, because we're lazy and we want to pick the easiest numbers possible, would pick -1. Okay, so plug it into the original. We have -1 to the 3rd power plus 4 times -1 to the 2nd power plus 4 times -1. Is it greater than or equal to 0?
Wait,
Okay,
wait, is the plus, is this supposed to be a negative before 4?
that's supposed to be a minus. You're right. Thank you. Minus, sorry. Now, this is where we get into trouble. -1 cubed is -1. Okay, your arithmetic with positive and negative numbers is screwing everybody up. This is minus 4 times regular 1. -1 squared is 1. So minus 4 times 1 plus -4. So this is -1 minus 4 minus another 4. Plus negative is this. So notice this, because we're using negatives, goes way back to chapters 1 and 2 when we had to practice all of our math with positive and negative numbers. This works out to be -9. Is -9 greater than or equal to 0? False. Now, I want to erase my work. Okay. If I don't see this on exam number 3, okay, you will automatically lose 2 points off of this test. So the way this is going to be graded is you're going to get a couple points for getting the correct critical values. You're going to get a couple points for showing me the intervals with the words true and false and your test numbers on there. If you don't show me that, you're going to lose those points. Okay. Now, lastly, we have to decide what's true in this problem. okay? Or what's our answer? So our answer in this case, okay, is everything that's true. Well, in this case, it goes from 0 to infinity like this, because 0 to 2 and 2 to infinity. So 0 to infinity, okay? In the one on the homework, excuse me, the one on the quiz, 0, well, I forget. The pattern was true, false, true on the one on the quiz. So let's say this was 5 and this was 9. Then this one, with the proper work, your answer would have been parentheses, negative infinity, comma 5, bracket, union, because you have to combine it with 9, comma infinity, parenthesis like that. But everybody got a slightly different problem, so I can't tell you what your critical values are. But pretty much the pattern was true, false, true on the quiz. So your answer looks something like this. This part was true, so you wrote it in interval stuff. This part was true. But my big hang up right now is I saw all kinds of weird things for the interval test, but not this. Okay, so I went and graded it accordingly, and I'm going to grade it like that on exam number 3 also. 2 problems that require the interval test on exam number 3. 2 problems that require you to use this. Any questions on that?
If the denominator is, let's just say x minus 1, and then it's the same. Okay, you know what I'm about to say.
Yeah, okay. So wait, before I erase, any questions on this work? Because if I answer Vincent's, it's a totally different, it's a slightly different problem. Same concept. Any questions about this at all? Okay, Vince's question. What he is asking is, suppose I give you a fraction like x over x plus 2 is greater than or equal to, I don't know, 5/3 or something like that. Okay. Well, let's make it, yeah, okay, 5/3. Do you want me to just walk down to the critical values? Because this is what your question is.
Yeah, that's cool.
Okay, so again, we'll treat it as x over x plus 2. We pretend it equals 5/3. I'm going to cross multiply. So 5 times x plus 2 equals 3 times x. Now I solve this problem. So this is 5x plus 10 equals 3x. Take away 5x from both sides, I have 10 equals negative 2x. Divide, I have negative 5 equals x. Now, hold on, we're getting real close to Vince's question. Is everybody okay with my steps on this problem so far? Okay, this is a really good one. Hint, hint, for the test. Okay. Okay, so you got a fraction. I chose to cross multiply. Who the hell knows what Carmen's going to do, but it was easier to make it to cross multiply. Solve, we get negative 5. This is a critical value, but you know what else is a critical value? X can't equal negative 2. That's also a critical value because the restriction. Remember, when there's a fraction, there's a restriction. The denominator can never equal 0. Okay, so you know, oh, that means x can't equal -2. So those are two critical values. Here's the critical value we solved for, -5, and here's the critical value that was implied because of the denominator. Okay, so then we go to our interval test. Okay, we put -5 and -2 up here, and this is also hitting on Vince's question. Okay, are they both solid? Okay, because of that equal sign, are they both open? What happens?
Run us the answer.
So what?
-5 is solid, -2 is open.
Yes, exactly. We can hit -5. That's okay because of the greater than or equal to. But we can never have -2 as a hit that, because if x were -2, x can come close to it, but it can't touch -2 because it would cause our fraction to just blow up. So I'm not going to continue with the math on this. You guys can work this one out. You can plug in numbers and they get ugly. Use your calculator and decimals or whatever. But the key was, do you take from the denominator? Yeah, whatever makes the denominator undefined, that also becomes a critical value. It goes up here. It almost always will have an open circle. If it came from the denominator, it will almost always have an open circle. Okay. And again, you guys can test values and do all the rest. But Vince, that is your question, right?
Yes, sir. Thank you.
Okay. All right. Before I erase and move on to a new problem that people had trouble with on the quiz, is that okay? I wasn't intending to do this, but it was a really good question. So I've given you one problem that I worked all the way through with interval testing, another problem that I've worked about 3/4 of the way through with interval testing. We still have to test intervals and that kind of junk. And I would still expect to see this on your test. Any questions about either of those? Okay. Let's take just a quick short break from learning math. We'll come back to it in just a second. We do have a quiz on Thursday. Actually, we have two quizzes on Thursday. Okay, a quiz on the first 3 sections and a quiz on the last 2 sections, 2.5, because there's word problems. Okay. This quiz is going. This is it. Functions, exponentials, inverses, okay, some easy logarithms. That's this first quiz. And you guys were asking good questions tonight on that. The second quiz is what I wanted to vote on. I'm ready to give it to you on Thursday. Okay. But I'm also willing to move it back to Friday, to Saturday, to Sunday, or to Monday. Okay. Depending on how the class votes. So I'm ready to give it on Thursday along with this one. So it'd be 2 quizzes or just one big hairy quiz, whatever, or one quiz on Thursday and a second quiz on another day, but it would have to be over the weekend sometime. Friday, Saturday, Sunday, perhaps Monday. So what I want to do is I want you guys to think about this. I don't want to make the decision tonight. Okay. We're going to vote on this. I'm going to put a poll up tomorrow in Zoom, and we'll vote on what the class wants. Each one of you knows kind of your own preferences. You know, you're having a big old giant party this weekend and just want to get it out of the way on Thursday, or do you spend the weekend studying, that kind of stuff.
Would it be open on Thursday and then due on Monday, or just open on Monday and that's it?
It would be open on Monday and that's it.
Okay.
I mean, if you opened it, If you open it on Thursday to Monday, we would still have the same time to do it if we did it within that time frame, right? It would still be like that hour time clock. So would it matter what day we took it, right? Because you're still, it's a timed quiz. So I mean, that would actually benefit anybody, the whole class, I think.
That's the good.
I'm trying to think if I can do that.
You did it on chapter 7 quiz, I think.
Yeah, wasn't that 2 days or something like that?
Yeah, it was like yeah, I
Open
think
it.
it was 2 days.
I could open. You want it open maybe for the whole weekend, but a limited amount of time.
Yeah, because
All the quizzes are timed, aren't they?
Yes.
Yeah, but the timing has been BS. Very few of you have needed all the time for the quizzes. Now, you've needed all the time, many of you, for the tests, yeah, but for the quizzes, most of you guys, most of the class, I give you, 70, 80 minutes, and you guys are calling me back going in 15 minutes going, can I do some more? So
not once has that happened yet.
not for you. Okay, well, okay, maybe not can I do some more, but many of you have finished quite a bit early. I can do that. Well, let's talk about that tomorrow night. I'll modify my my poll a little bit. I can do that, so I make it open on Thursday night, but give you a limited amount of time to work it. You can do it sometime over the weekend, but before class on Tuesday. Is that okay with everybody? Do you just want to go with that one right now?
Yeah.
I'm down with it.
Yes.
Oh,
Yes.
that
Yep.
weekends work so much better for workers.
Much better.
But I understand what you're saying, Professor
Okay,
Foster. But
but now I'm giving you all worlds. This is the best of all worlds. If you want to do it on Thursday, cool. If
Right.
you want to do it over the weekend, that's also cool, but it is going to be time.
it's available, but if it's once we open it, we're being timed, right?
That's right. That's how it would work. Yes.
Okay.
Is that okay with everybody? Tonight I'll just go in and make those changes.
Yeah, I like it.
Oh, that'd be wonderful.
I'm on board.
Okay. I'm sorry?
Yeah, I said I'm on board. Yep.
Okay, all right, cool. So I'll go make those changes tonight. The other thing is, some of you weren't here. We talked earlier. There will be tutoring for summer school over the summer, but they haven't set their schedule yet. So as soon as I find it, or one of you find it, or Ann finds it, let us all know. Okay, but as soon as I find it, I'll send you guys an email or post it somehow or do something for you. Those of you thinking about taking a math class or something over the summer. Okay, and then Mitch found out that net tutoring is always available. Jan, you were the one talking about net tutoring for your other classes?
Yep.
Yeah. So it's free. The Mesa pays for it. And Mitch was saying they were telling him that it's always available for all of your classes. And if you look on the Canvas homepage, on the left-hand column of the homepage, Net Tutor is one of the things you can select on my Canvas page, or any instructor's Canvas page for that matter, but you can go there. And I'm going to say that if you find the STEM Center tutoring, I bet you they could also hook you up with net tutoring, even if you didn't have Canvas. I bet you they could hook you up some other way. Okay, so, but we'll find that out. All right, so anyway, just keep you guys, and just to let you know, Vince says that Mortal Kombat sucks, don't waste your money. Okay, so that's all we've talked about for everybody else. Okay, let's go. Next question. I was a little bit disappointed in the number of people who just left this blank. Okay, it was a projectile motion problem. A rocket. Projectile motion. And we give you something like this: h of t equals -5t squared plus 35t plus 140. Okay. And people just left it blank, left the whole question blank. It's going to be on the exam, and leaving it blank on the exam will kill you. So we need to work on this. Okay. H of t is the height at a certain time. How high is it at a certain time? The 140 is the initial height. Okay, I'm not sure you need the rest of the garbage right now, but this is the formula of a rocket going up in the air. Okay, it starts at 140. Now, I have to tell you, t equals seconds or minutes or whatever, and h is equal to meters. Now, it said that in the problem. Okay, there's another thing that you need to know is the English word in English. In this context, the word when, W-H-E-N, implies time. So when is the rocket's certain height means find the time. When means time. Okay. And they always gave you something like this. The time might have been seconds or minutes or hours or something like that. Okay. The height is always distance, meters, inches, miles, whatever. So t is time. Okay. H is in meters. H of t is how high is it? It's height. How many meters is it after a certain number of seconds? That's what that says. This particular rocket is starting at 140, going up, coming down. Okay, that's what that's saying. The rocket is starting, its initial means at the beginning of the problem. So the initial height is 140. So it's starting at 140 meters. It goes up because rockets usually do. Well, unless mine just always kind of went around the ground and we ended up dancing out of the way. But that's a story from my youth. I have a really bad joke, and I'm not sure I should.
Do it.
Well, I couldn't get it up. Never mind.
Oh my God,
I'm dead.
that's a
Okay.
Mitchell's dying laughing right now.
Well, that's what happens to my rockets in my youth. Okay, never mind. So this says the rocket started at 140 meters, went up, comes back down. All right. The first question on the quiz was something like, when does it hit the ground? Okay. And again, I was just aghast at the number of people that left this blank. Okay. When means find the time. What is the time when h equals 0? The ground means the height is 0. When we're over here, how far up are we? 0. So that translates into 0 equals -5t squared plus 35t plus 140. Okay. So these words, when does it hit the ground? When means find the time. And notice if we solve this equation, we'll be solving for time. When does it hit the ground? Okay. And ground always means height is 0. So h is 0 right there. What's up? Okay. Do you guys need me to solve it from there, or is that okay? Does that make sense to everybody? Because like I said, several of you left it blank, and you can't afford to do that when exam 3 comes around next Thursday. Go look
Do you
at
know
your
how
schedule.
how
Yeah,
many
go
are
ahead.
going to be on exam 3 of these?
How many what? You mean
How
questions?
many of these problems?
I don't recall exactly, but if you go to Canvas, I think I've opened up the exam 3 module and it has a breakdown of what's on there. It has a practice multiple choice test, okay, and it also has a breakdown of how many questions are on which. Okay, I honestly I don't remember exactly. I wrote it about a week and a half ago, and my brain just doesn't work that way. All right, so can I assume you guys could probably solve this? Personally, I would make it as 5t squared. I'd bring everybody over here, minus 35t minus 140 equals 0, because my personal hang up is I like my t squared coefficient to be positive. Okay, that's just a Fosterism. I like that. It means less chance for mistakes. You didn't have to bring everybody to the other side. You could have multiplied everybody by -1 and achieved the same thing. The next thing I personally would have done was factor out the 5, leaving this as t squared minus 7t minus 28 equals 0. Okay, t squared minus 7t minus 28. I'm going to guess that it doesn't factor. So you pop everybody into your calculator. T, not x, but t equals positive 7 plus or minus the square root of -7 squared minus 4 times 1 times -28, boom, all over 2 times 1. The problem will say round it to a certain decimal. So you don't have to worry about pretty square roots or anything like that. You can just get this answer and then let your calculator do all the work in decimals. By the way, you will probably get a negative answer and a positive answer. Okay, question, do you want me to continue this, or you guys pretty much have the idea?
Yeah, I get it.
Okay, so again, I'm telling you, okay, tonight we've talked about several problems that are going to be on the exam. There's going to be 2 quadratic inequalities where you have to use interval testing with the number line thingy like I showed. Okay, there's going to be, and I even, well, Vince asked the question and I told you that was on there. Okay, there's going to be at least one projectile motion. There's going to be another kind of problem, but at least one projectile motion on the exam. Okay, so I'm going to, over the next couple of days, spend more time doing this, but I wanted to talk about this one right now. The basic ideas. All right, enough. Let's get into new stuff. Let's go back to logarithms. Unless somebody has a question about what I've written up here tonight so far. Anybody? Or any questions about am I fit and qualified to teach since I have such bad jokes? Those are other questions that could be asked.
I think that should be mandatory of all teachers and
What?
professors.
I've seen some that, oh no, I don't want, no. I've seen we have a couple in our department that if they ever told a joke, if they ever smiled, I think their face would fall off. Okay. My feeling is that while I enjoy math, I also understand that it can be incredibly boring. And anything we can do to lighten it up is helpful. Because I go back, let's see, what was it? Little Larry had to repeat algebra twice in middle school. Me, it didn't make sense to me. I failed it and failed it. I was a bozo.
I think you're lying to us. You were probably just a big troublemaker.
Well, that too. That too. I had a guy in high school. I had a teacher throw me out, and he wrote on my referral. He wrote persona non grata, which means this person isn't acceptable in my class. And I couldn't go back in until my parents had to come up, and he got to ream them. And then, of course, you know, since they got yelled at and they got embarrassed, you go ahead and think about what happened to me. And remember, back in the 60s, spanking was still okay. So I got whooped. Okay. All it meant was that I got more subtle in how I disrupted the class. But I thought I was funny. I don't know why he didn't laugh. All right, here we go. In chapter 10.3, excuse me, we introduced, okay, the beginning of log laws. And the most important one, which is going to come back to haunt us all the time, is what I called the bar-bra rule. Okay. It's technically called the definition of logarithms. Okay. And it's not the letters that matter. Okay. So if you have log base b of a equals r, if you have that pattern of letters, then that is equivalent to, okay, b to the r equals a. That's the definition of a logarithm. Now, I told you that a logarithm was an exponent, was a weird exponent. Okay, but that's what it says. If you have a logarithmic equation here, you can convert it to an exponential equation with no logs in it anymore if you move these letters, the BAR, around in the correct pattern. If you get the pattern screwed up, you're dead. So if you start with log of a bar, log base b of a equals r, bar, log of bar, you end up with the exponential bra. There's a joke there too. Never mind. I'm in too much trouble. Okay, so that's the definition of a logarithm. Okay, in every book in the universe, they may not use BAR. They may say log base x of y equals z is the same thing as x to the z equals y. That pattern is the same pattern up here, except x, y, and z don't make sense. They're just stupid letters. Bar and bra makes sense. So that helps you to remember somehow. The key thing that you have to remember as students is converting from exponential form to log, or from logarithmic form to exponential, converting at will quickly. Now, there's some other things that we talked about, and I'm going to have to erase these because we don't have room on this whiteboard. But we also talked about another log law. It was the log base b of b always equals 1. So an example of that might be log base 2 of 2 will always equal 1. Okay, if the base and that number are the same. Okay, if the base, and that's called the argument of the function, whatever. But if the base and that number are the same, it's a log of that, it always equals 1. Okay, if we have the log base b of 1, it always equals 0. Okay, so for example, and you could do this on your calculator, if you had the log base 7 of 1, you could say, that's just 0. Okay, that's it. And then, okay, the last one we talked about last week is called the power rule. I didn't give you a name for it last week, but it basically said, if you have the log base b of a raised to some power. Now notice a is being raised to the power. If you have log base b of a being raised to a power, like that, then you can, if you wish to, see, all of these rules are always if it helps you. If you wish to say log base 2 of 2 is 1, go ahead, it is. Okay, if you wish to use this rule, this becomes p times the log base b of a. Well, look what happened. The power just gets moved out front as a multiplier, p times that. Okay, so an example might be, okay, what if you have the log base 2 of, I don't know, let's say x to the 5th power, like that. Log base 2 of x to the 5th power. Well, according to this power rule, it becomes 5 times log base 2 of x. You can move the power, you're allowed to move the power out front if it helps you. Okay, it may or may not help you, depending on the rest of the problem. Okay, now I'm going to have to erase this because I want to go through the other rules here. One of the things I asked you guys to do over the weekend is, can't read that. Good job. Okay, where's my, let's see, video. Well, this says it is using my, well, I don't know. Yes, you can't read. And I was going to try and put it somewhere. Anyways, it's this properties of logarithms or log laws. I asked you to download and print out if you could. It was on chapter 10 module. I asked you to print out a couple other things, but it doesn't show up. I was helping some students several years ago. Notice the date really down on the bottom is Kirk Thompson. He was a student, he was a tutor, and he had been helping students, and he wrote this in 2011. And one of my students had this in class, and I liked it so much, okay, that I borrowed it and made copies. Actually, let's just call it the truth. I stole it and made copies and have been using it ever since. It's really cool. It outlines almost all of the rules that you're going to need in this chapter. There is an error on here, and I just caught this a couple years ago, and I really don't want to rewrite it. look down where it says other general properties, other general properties. Okay. If you look down, you'll see something that says the ln of m equals the ln of e, base e of m. If you printed this out, you should find that one. And that is wrong. He made a mistake. That is wrong. It turns out, and I'll try to explain this later, but I want to clean this up on your on that handout right now, that the log, L-O-G, base E of something, X, log base E is the same thing as the ln. Ln implies that it was base E, ln of X. So when you say ln, you're saying, oh, that's a logarithm base E. And that's built into your calculator. So while that may not have much meaning to you, what he should have written up here is this: ln of m equals log base E of m. So the ln is a shorthand method for log base E. So instead of writing log base E, you can write ln. They stand for the same thing. So please modify his worksheet. That one thing is wrong. It should be log base E of m right there. And now I'm going to boggle you with about 100 gazillion formulas. I'm going to go through these. Where is, there it is. Yeah, these are crazy. Sorry, I'm getting another ink. Okay, so if you look at this, this handout, we've already talked about the power rule. I know you can't see it, but if you print it out, it'd be great. On the left-hand side, third one down, it says the power rule. We've already talked about that. Okay. We actually have talked about the change of base rule. If you recall, last week, log base 3 of 7, I had you guys doing that on your calculator. Some of you have a calculator will do that automatically. Some of you don't. You can change that to log of 7 over log of 3, and then calculate each one of these separately and divide. That's called the change of base rule, and that's what that says. Now, we'll be doing more examples of that, so don't panic, but we've talked about that already, okay? We've talked about where it says general properties, log of m, okay, was called the common log, and it implied log base 10 of m. So whenever you write the word log without a base, L-O-G, and you leave the base off, everyone will assume you meant base 10. If you meant something else, you have to write it. If you meant base 3 or base E or base whatever, you have to write it. But if you leave it off, it's implied to be base 10.
Professor,
Yeah,
I'm sorry, I'm running a little late. Could you turn on the captions for me?
sure.
Uh,
Where'd you go? Wait a minute, where are you? Okay, come on. Come on, where'd you go? No, no, no. Ah, Sandra. Nah. No, I don't want to make you co-host. I want to turn on the captions, damn it. Oh, you haven't been here?
No.
Then, oh, thank
No.
God, because then all the inappropriate things I've been saying haven't captioned. Oh my God, am I
Thank
happy?
you.
Okay. How about, does my captioning interfere with your captioning? No?
It does. It does everything double.
Okay, then I tell you what, I just killed my captioning.
Thank you.
Uh-huh. Stop that. Okay. Whew. So there is no proof that I did anything inappropriate. Wow. Okay. I'm lucky.
The Zoom is recorded.
Uh, yeah, it is. But I never save the transcript. I only save the video. I wonder if I can edit that out. Do you know how hard it is to edit a video on YouTube? It's a pain in the rear. It really is. Okay. So anyway, a lot of the properties on this page we've already discussed. I'm going to be doing problems, and you'll see them on the page, and maybe this page helps you, maybe it doesn't. But there's a couple rules that we do have to talk about. Okay, and they're the first two rules on the page. The first rule is called the not the product rule. Okay, is the product rule. We'll call that, not the power rule. This is the product rule. Now remember, the word product means multiplication. So if you have the log base b of m times n. Now look at that for a second. If you take the logarithm of two numbers multiplying together, you can, if you wish, separate it into the log of the first number, base b of the first number, added with the log of the second number. The laws of logarithms allow us to either take two separate logs that are adding and condense them into one log of multiplication, or take one log of multiplication and expand it into a log of addition. So two logs of addition. So for example, suppose I had the log base 3 of, I'll be simple right now, of 2x. I'll keep it simple. If you wanted to, you could convert this into the log base 3 of 2 plus the log base 3 of x. Because what's happening when we write in algebra, when we write 2x, we mean 2 times x. So that's what's happening. That's what this rule says. But the rule is bidirectional. It says you can go backwards also. So what if I had the log base 5 of y added with the log base 5 of z? What if I had two separate logarithms that happen to be adding together? Two separate logs that are adding can be condensed into one log that is multiplying. So this could be turned into log base 5. That's always got to be the same base of y times z, whatever that is. So I'm going to erase my examples up here And this handout has more examples on it for the product rule. Okay. The log of two things multiplying can be expanded into two separate logs adding, or the log of two separate things adding can be condensed into the log, a single log of one of things multiplying. All right. Then that was the product rule. Product means multiplication. What's the opposite of multiplication? Anybody? Division. And so
Division.
quotient, Quotient, the quotient rule. The quotient rule says if you have the log, base B, of two things that are dividing, remember quotient means division. So if you have the log of two things that are dividing, you can separate them into the log of two separate things that are subtracting. The log of a division problem, m divided by n, can be separated, expanded out into two separate things, two separate logs that are subtracting. So for example, if you have the log base 4 of, I don't know, x over 5, just to make up something, log base 4 of x over 5. You can write this as the log base 4 of x. The top is always top down. So the top number comes first, the bottom number second, minus the log base 4 of 5. So the log of a single division problem can be separated into two separate logs that are subtracting. Okay. Now, what I'm going to do is I'm going to start doing a few problems to show you how exactly I'm going to test this. Okay, and how mom is going to test this. I thought I turned that off. Didn't I turn that off? Or is that, Sandra, is that you? I guess I turned.
Yeah, that's me.
Oh, okay.
Yeah.
I just never paid any attention. Okay. Well, all right. So those are the basic ones. They're at the top of this handout. Okay, along with some other ones. Now I'm going to give you almost exactly what I'm going to test you and what you're going to see on mom. So the first thing we're going to see is it'll say expand. So for example, the log base 3 of 2x, oh, I'm going to say expand and simplify, but you see this, 2x over 3, like this. Okay, the log base 3 of 2x over 3. Well, the first thing I see is a fraction. Okay, so this is going to become the log base 3 of 2x minus the log base 3 of 3. That's using that quotient rule that I just erased. The log of two things dividing, top divided by bottom, becomes two separate logs that are subtracting. Yeah, okay, fine. Okay, then I'm looking at this was 2x. But when we write 2x, remember that means 2 multiplied by x. So I can use the quotient rule to say this is the log base 3 of 2, not the quotient rule, I'm sorry, the product rule, product multiplying, plus the log base 3 of x minus 1. Okay, and I probably just made you wet your pants right there. So let's go back. This is my final answer, by the way. I'm done. There's nothing more I can do to this problem. So the first question I ask of everybody is, do you understand how I went from the log of a fraction, division, to two separate logs that were subtracting? Is that okay? That's called the quotient rule for logarithms.
Yes.
Everybody, is any hesitation on that from everybody? You're okay. Next question then, do you understand how I viewed 2x as 2 times x? So I have the log of a multiplication gets expanded into the log of the first plus the log of the second. Is that okay with everybody? That's called the product rule.
Yes.
Okay. Now, what happened here? How did this become a 1?
They're the same.
The -1.
Right, the log base b of b, where was it? Oh, it's somewhere under the other general properties. Down there, it's the first one under other general properties. If you have this, the log base b of b becomes 1. So we would say that's simplified completely. Or excuse me, that's expanded completely. I should be more clear. Okay, let's try another one. What if I have the log, I don't know, base 5 of 7x quantity squared. The log base 5 of 7x quantity squared. Well, the first thing I see is the power. So go up and look at the power rule. It's the third one down. What can I do with that power of 2?
You can put it in front, multiply it by the log.
So the first thing I would do is bring the 2 in front and write 2 times the log base 5 of 7x. Now, you guys don't have to put the dot there for times. I'm putting it there to stress the rule. It's 2 times that log. Okay, most books will just put 2 log. All right, do you guys see another rule that I could apply?
The m times n rule.
Yeah, 2 things that are multiplying together can be blown apart. So this becomes the log base 5 of 7 added with the log base 5 of x. Now, I need to back off. I realize that I'm being very inconsistent. Sometimes I'm writing the parentheses, sometimes I'm not. To be really accurate, I should always be writing these parentheses, log base 3 of 2. The 2 should have been in parentheses. Log base 3 of x. The x should have been in parentheses. Okay. You can get by without it, but it's better not. It's better to put the parentheses there. All right, back to this problem. I'm sorry for jumping around. So we took the log base 5 of 7x and split it apart that way. What about the 2? Well, it comes down.
By 2.
Pardon me? Say again?
You times the whole thing by 2. Like put it
The whole
is-
that, yeah, I'm glad you said the whole thing. It means all of it times 2, because this is 2 times this mess. So even though you expand the mess, it's 2 times the expansion of it. Now, whether you distribute the 2 in there or not, that's open. That's open for debate. Maybe 2 log base 5 of 7 plus 2 log base 5 of x. Again, with parentheses and all that other crud. But I would accept this as full credit. I'm not sure what mom would do. In some cases, she wants you to distribute the 2 through there. But those are 2 examples. I'm going to go one more. I need to erase the board or erase some of the board. But those are 2 examples of expanding using your knowledge of the log laws that's on this paper that we've talked about to look at this expression and just expand it out using as many log laws as you can to do this problem. Okay, I want to do one more before I erase the board. Does anybody have any questions or comments or anything you want to ask about?
I have a question, but I hope it doesn't throw you off of your flow too far.
Okay, go ahead.
So there was a question on the homework that was log, the base 4
Base.
of 4,
Yeah,
and then power 12.
yeah.
So when I did the math without moving the power, it was 12. But when I moved it, or sorry, it was 1. But then when I moved the 12 in front, it was 12. Does that make sense?
No. Yeah, it does. I mean, okay. So you had the log base 4 of 4 to the 12, right?
Yes.
Okay. Now, the one way is to call this 12 times log base 4 of 4. But the log base 4 of 4 is 1. So this becomes 12 times 1, which is 12, which is the correct answer. Okay. What did you say you did on your other way?
So so there wasn't parentheses. So I first did log 4 of 4, which is 1, but I left the power of 12 there, and then 1 power of 12 is 1.
Okay. Yeah, no, in a weird kind of way, you violated Aunt Sally. Okay. You have to bring the power out. You got to use the power rule first before you use those other rules.
Okay, so you, in that case, you have to do that?
Yeah. If you
Okay.
see that these are going to cancel somehow, yeah, you got to bring the 12 out of there.
Okay. That makes sense then.
Okay. Yeah, it is a variation of PEMDAS, because remember, exponents come before multiplication, and this, whatever, that exponent rule happens first.
Oh, okay. Thank you. I was just a
Okay.
little confused by that earlier.
All right, no, that's okay. That's a good question, and that's one of the things that you just got to practice on when you get to your homework. It's just logarithms are a whole different way of thinking, and you can't learn them in one day. You've got to learn them over time, screw up, think about your mistakes, and relearn them. Logs are just really different.
So I have a question.
Yeah.
So how do you know when the problem is finished? Because the answer is just like so weird.
That
Like, do you just check your log laws and you're like, okay, I can't do anything else? I don't know. I just feel like that was.
Yeah. That question is much more universal for all students. When do I know I'm done with a stupid problem? And not just logarithms, any problem. And I hate to say it, but it just comes from experience.
Okay.
And just looking at it, it's a really good question, because that's the one thing that students really, they've got all these things in their mind and go, okay, what do I do? What do I do? What do I do? And the answer is, can you think of any other log law that applies to this? Okay, that makes it expand more? No, so I quit. Okay. And yeah, you might screw up a little bit, but I'm going to tell you something. Of the examples I'm going to show you here, okay, I'm only going to have 3 of these on the entire test. I really find, I understand what you're saying. And because you're not solving anything, because you're just showing me knowledge, it's really hard to know when to stop. So I have made my test in a certain way that I only have a few of these problems on it, so you won't get too screwed up, or your grade won't get too screwed over if you really struggle with this. Did that kind of make sense or not?
For sure. Yeah, yeah.
Okay.
And
All right.
for the exam, you don't want us to, I mean, you'll just know what rules, what laws we're using. We don't have to like write, okay, we're
No,
using this
yeah,
power rule.
exactly. Like just like I did here. You do this, I know what you did.
Okay.
Okay. So here's a last one. Log base 3 of the square root of 9x. Okay. I want to get you started on this, and then I'll let you guys work on it for a second or two, just to get a flavor on it. Okay. Do we have, I'm holding up the wrong sheet. Do we have a log law for square roots? Can you look down here? Is there any log law on this worksheet for square roots or cube roots or fifth roots? No. But we know from previous chapters that the square root is actually the half power. See how devious mathematicians are? We don't have a square root rule for logarithms, but we know how to change the square root into the half power. And now we do have a power rule for logarithms. So I'm going to pause, give you about 2 minutes to kind of play with that. So we're going to move the power down half times log base 3 of 9x. We're going to take the 9x and expand it. So that's a half times the quantity log base 3 of 9 plus the log base 3 of x. Okay. There's a couple of ways that this can be simplified. Log base 3 of 9. There's three. One is you could just put it in your calculator and get the answer of 2. Okay, the answer is 2, but I want to show you how to do it without your calculator. Okay, so I'll finish this off. This is 1/2 times 2 plus log base 3 of x. If you distribute the half in, where's my glare? Glare, crap. Right about here. This is 1/2 times 2 plus log base 3 of x. Okay, so if you distribute it in, you get 1 plus 1/2 log base 3 of x as the final answer. So I'll show you in a minute. I'll go off of my scratch paper and show you how I work that one out to become a 2. But that's your steps for this particular problem. 2 keys or 2 tricks in this problem, which make it a kind of good one. The radical can be written as the half power. Remember, the square root is the half power. So now we can apply the power rule for logarithms. And then this log base 3 of 9 simplifies into a 2. And I'm going to show you how to do that right now. Okay. So I'm going to show you method number 1, log base 3 of 9. This is log base 3 of 3 squared. 9 is 3 squared. Move the 2 out, use the power rule. 2 times log base 3 of 3. And that becomes 2 times 1, because base 3 of 3 is 1, so 2 times 1 is 2. That's one way of attacking this problem. One way. Okay. An alternate way of attacking this problem, and you'll see a lot of instructors do this. They'll say, I know it's something, I'm not sure. So they'll make it into an equation where X is the answer. They'll say, I don't know about that, but 3 to the log base 3 of 9 is worth something. So X is its answer. But then apply the Bra-Bar rule. Apply the Bra-Bar rule. 3 to the X power has to be 9. 3 to the X power, many students learn this, 3 to the X power has to equal 9. That's a variation from the Bra-Bar rule, but 3 to the X power has to equal 9. Well, now, wait a minute. Use your common sense. Use your math knowledge. 3 to what power equals 9? 2. So you get the same answer, X equals 2. Okay, whichever we got there. 3 different ways. You could have used your calculator. Okay, but you could have also used some of your knowledge of logarithms. All right. Notice all of these problems were expanding. I gave you a nice problem and asked you to just apply every rule that you could think of, okay, to make it just bigger and bigger and bigger. Just apply every stinking rule in the book. So, questions about these before we go to the opposite of expanding, which is condensing or contracting.
Professor, I got a question.
Yeah.
So when you have the radical over that 9x, but then on the next, you convert it to the log of base 3, 9x to the half power, aren't we getting rid of the square root or whatever you want to call it? Sorry.
Okay.
Aren't we getting rid of the radical already, or the square root of that 9?
You didn't get rid of it. You just wrote it in an alternate form. What I hear you saying is you want to do the square root of 9 and get 3.
Right.
Okay. Yeah, and yes, you could have gotten that also. Why am I getting messages up? But what if I called this an 11? What if that was the square root of 11x? Well, then the problem would be screwed up. Then I couldn't show you anything. Damn it. Okay. Yeah, what you're pointing out could it have been done another way entirely? Yes, it could have. Okay. Let me show everybody what I think you're saying. Stop me. Okay. What you're saying is, looking at this problem, this is the log base 3 of 3 times the square root of x. Because the square root of 9 is 3, it can come out. So that is timesing, so this becomes a log base 3 of 3 plus the log base 3 of, instead of, well, I'll say the square root of x because I don't want to skip too many steps. Okay. Yeah. Okay. But the log base 3 of 3 is 1, which is what we had, plus the log base 3 of x to the 1/2 power, because the square root is the half power, And then you can move the half power in front. So 1 plus half times log base 3 of x. And so you notice we got the same exact answer. So what I hear you saying, Richard, is if I saw that as a square root that I could do, could I do it? And the answer is yes, you could have.
Thank you.
Or
Thank you.
is that kind of what you were getting at or not?
Yes. Yeah.
Okay. All right. All right. So you just hit upon a totally new, different way of doing the same problem. And again, I'm going to say this repeatedly, as we get more and more sophisticated, and you guys are all showing me levels of sophistication, there's more than one way to beat a problem. Okay, and you're all using proper algebra in a different way to get to the same answer, and that's great. That's awesome. All right, let's go on to another one unless somebody has a question or clarification. Okay. Then the opposite of expand is condense. Okay, and that's what the instructions are going to say. It'll say condense this. So condense. So 2 log base 5 of 6 minus log base 3 of x minus log base 3 of y. Okay, please watch this. Okay, there's going to be a couple questions in mom that you guys are all going to come back and go, how do you do this? Well, this is it right here.
Is that a base of y or no?
It should be base 3 of y. Thank you. Base 3 of y. Okay. I'm going to do it first an algebra way, second a wrong way, and third a shortcut way. Okay,
Did
so
you
here we
say a
go.
wrong way or long way?
Wrong way.
Okay.
You'll see. You'll see. Okay, so this is log base 5 of 6 squared minus quantity log base 3 of x plus log base 3 of y. Now, look at what I did here. I factored a -1 out of both of these because I noticed they were both negatives. So I factored a -1 out. That's why that turned into a plus. Okay. Well, this becomes log base 5 of 36 minus, all right, what do I do with 2? How can I take 2 separate logs that are adding? How can I condense them? What do they become?
X times y.
Log base 3 of x times y. Okay. So now, what do I do with 2 logs that are subtracting? I have 2 separate logs that are subtracting. How do I? Division. So this will become log base 5 of, the first number goes on top, the second number goes on bottom, and that is my final answer. And that's using proper algebra techniques. In a minute, I'll show you how to cheat.
Where'd the
So-
minus sign go?
In the rule.
Oh, that's right. No, okay, never mind.
You okay?
Yep, I got it.
Okay. The minus sign became the division.
That's
Squished
right.
into the, yeah. All right. Anybody else? Is that okay? the tricky part here is how in the world are you, the student, going to remember to factor out a negative? Okay, well, I'll show you in a minute. All right. So what if we did this? Log base 5 of 36 minus log base 5 of x minus log. Oh, those are all supposed to be base 5s. I'm sorry, I really screwed this up, guys.
Okay, yeah, that's what I was wondering, like, because doesn't it have to have the same base?
Yeah, they all have to have the same base. So go back in your notes. I really blew it. Change this into, the easiest is change this into base 3. Instead of writing
Who did
everything
you
else.
violate now?
I violated, well, I don't know. Who do I want to violate? Never mind. I better not say that. I'm gonna get in trouble. Yeah, I violated a big rule. I'm proving that talking, thinking, and writing all at the same time doesn't work. Okay. Okay. So they all should have been same base. So I really blew this example. Okay. They all should have been same base for any of this to work. Sorry.
If
All
they
right.
were the different base, would you just leave them separate and then that would be the final answer?
That's correct.
Okay.
Yeah, you would. So back here to this one, base 3, log base 3 of y. Now I'm doing this one semi-wrong to show you. Okay.
Wait. Does it have a 2 in front of it as well?
No, because I moved the 2 up and called it 36.
Oh, okay, I see it now.
I just jumped to that.
Okay.
Okay. Is everybody? Now, let's put these two together. That becomes the log base 3 of 36 over x. And that is correct math. That is correct. The log of two things subtracting becomes one big thing dividing. One big log. Minus the log base 3 of y. Well, the log, two separate logs subtracting becomes one big log. Dividing. Okay, and that's proper math. It's not proper form. We never want a complex fraction in our final answer. So we got to figure out some way to clean that up. And it's really messy and I don't choose to do it. But this is what I told you a few seconds ago was going to be the wrong way. Okay, nothing I did here was wrong. It just leads us to a really confusing answer. Now, we covered this way back in chapter 8, elementary. Okay, this was called a complex fraction, and you learned how to clean this up, what you would have to do. And if you clean it up, it'll become that. Okay, but do you guys understand that by doing it step by step, left to right, you end up with this complex fraction, and this is ugly, hard to take care of. And so while this wasn't a wrong method, it leads us to a really messy answer here. So let me show you the shortcut to all of this. Okay. It turns out that for logarithms, anything that was minus always shows up in the denominator. Anything that was positive always shows up in the numerator. Always. Look at that. The minus x and the minus y, the log of them, showed up in the denominator when I condensed it together. The 6 or the 36 was a positive. It showed up in the numerator. So shortcut time. What if you have log base 5 of x minus log base 5 of y plus log base 5 of z minus log base 5 of w. Let me erase this. Okay. Log base 5 of x minus log base 5 of y plus log base 5 of z minus log base 5 of w. Take a second, and that's all you actually need to shove this together and condense it. Who's on bottom?
Y and W.
Y and
Y.
W. And W, because it was negative. Don't forget that. And they're going to be multiplied together. Who's on top?
XZ.
XZ. And they're multiplying together, although you don't need that. That's it. That's the shortcut for when you have a whole bunch of logarithms that some are addition and some are subtraction. It will turn out, after doing all of your math, okay, that the positive logs will show up on top, okay, and the negative ones will show up on bottom. And you can take that one to the bank.
There's no like buts or except
Nope.
nothing.
Nope. Now, notice, wait, hang on a minute. If this had been a 2 log of x, then your first step, you would have to write this as log base 5 of x squared, bring the power in, and now you can do the rest of the problem according to what we just did. Okay, if this had been a half log base 5 of w, you'd have to bring this as the log base 5 of the square root of x, w, sorry. Because remember our discussion, the half power comes up here, but a half power means the square root.
So can we have a square root in the denominator of the X?
In this case, yeah, because we're just trying to get you to practice doing logarithms. Yeah. Okay.
Gotcha.
So the question was, will this always work? Is there a but somewhere? And the answer is, you have to have it as a log, not 2 times a log, but a log. And it can't be a half times the log, it has to be a log of somebody. So now when you shove all these together, you have the log base 5 of, all right, who's on top? X squared, Z, they're on top because those are the positive ones. Who's on bottom? Y and the square root of W. And this question is very good. Do we have to rationalize that? And in this case, my answer would be no, because all I'm trying to see is, do you know your log laws? That's all I want out of this whole mess. Okay. Are we okay?
Yep.
Yeah.
Okay, I want to move on now and just begin to introduce a little bit of section 10.5. I asked you guys, there's another printout on there called How to Solve Log and Exponential Equations. I'm going to start on that tonight, but go over this in a lot of I know you can't read it, okay, but it says how to solve, and I sent that in my last email. So I'm going to start on this tonight a little bit, okay, and then I'll come back and hit it in much more detail tomorrow night. Okay, so this is section 10.5, chapter 10.5, and we want to solve exponential equations. Now, exponential. Think about that word for a moment. Not logarithms, exponentials. Okay? There are two types. We've already studied one type. That was called same base. We already studied that last week. An example of that was something like 25 times 125 to the x plus 3 equals 1 over 5 to the 2x plus 1. Now I'll walk you through this one, but we studied those. All of these can be reduced, or rather rewritten, I should say, as the same base. All of these, if you look inside with your X-ray vision, are base 5. So 25 can be 5 to the second. 125 can be 5 to the third to the x plus 3. Equals 1/5 can be 5 to the negative 1 to the 2x plus 1. Okay, now again, we did these last week, okay, and we talked about each one of these, but I understand last week was last week and you probably forgot a lot. So the key is writing all of these so they're base 5. Now what we want to do is condense this into one base 5 on this side and one base 5 on the right side. Takes a couple steps. So this is 5 to the second times 5 to the 3x plus 9. Okay, because remember, power raised to a power, you multiply. Well, how do you do these two bases? How do I shove 5 to the second and 5 to the 3x plus 9 together? What do they become? 5 to the what? Anybody?
6x plus 18?
Nope.
5x plus 9.
11.
Plus 11.
Nope. No. Yeah, 11. Okay, because remember, if you had 5 to the second times 5 to the 7, just making that up, the rule says add the powers. Keep the base, add the powers. That's what the rule says. So we're going to condense these as 5 to the 3x plus 11. I'll write bigger. Sorry. Okay. So those two condense according to the basic rules of exponents. This one over here, we're going to use power to a power. So this is 5 to the negative 2x minus 1. Okay. So that was this is the same base exponential equation. The game is look inside each of these, try and change them all into the same base, and then condense everybody so you have a single base on one side, 5 to somebody, equals 5 to somebody else on the other side. That was the game that we talked about last week. At this point, we can drop the 5s and have 3x plus 11. equals negative 2x minus 1. Gary drop the 5s, and then try and solve this. What is this? 5x equals negative 12. Is that right? Take away 11 from both sides. Yeah. So I guess x is negative 12 over 5, and that should be our solution set, negative 12 over 5. Now, that was a quickie review from last week. Is that okay? Does that bring back fond memories of things that we were doing last week?
Yes.
Yeah, fond memories. Okay, I love it. Okay. Well, what happens if they're not the same base? Okay, not same base. So that's what chapter 10.5 is, or part of it is. What happens if the exponential equation is not the same base? Well, what would that look like? I'll give you a simple one. 2 to the 5x minus 1 equals, I don't know, 20. 21. There we go. That'll work. Okay. There is no way in the world you can write these with the same base. This is 2. There's no way you can put a 2 here. 2 to what power makes 21? I don't know. Okay. There's no way. So when you get this, okay, when you see this, this is where you have to learn a new technique to attack this type of problem. Unfortunately, like I just said, there's more than one way to do this. I'm going to show you 2 ways. The first is the most common way. The second is a trickier way. Okay. The best, most common way is to take the natural log of both sides. There's a reason I'm pushing natural logs. Okay, it'll make sense tomorrow night, I hope. Take the natural log of both sides. Now remember, the natural log, the ln, is just a log. So you can use your log laws to bring the power out front. Remember, that's a power times the ln of 2 equals the ln of 21. So right here, I took the ln of both sides. That made everybody a logarithm. ln is just a fancy logarithm. So by writing the ln of both sides, I've made this into a logarithm. Because it's a logarithm, I'm allowed to bring the power out front. Okay? You guys with me, kind of, sort of? Okay, here we go. All right. Now, I can divide both sides by the ln of 2. Now, I just didn't show this, but what happened here is I want to get this, kind of comes back to Carmen's question way back at the beginning. Okay, I need to get rid of the parentheses. Okay, the easiest way is to divide this side by the ln of 2, this side by the ln of 2. Okay, you guys with me? At this point, we're going to go to our calculator. At this point, we're just going to say, you know what, screw it. We're going to use our calc. So what I want you guys to do is on your calculators, calculate the ln of 2, 21 rather, divided by the ln of 2. Okay. And where's the glare? All right. So I have 5x minus 1 equals, can you guys see the 5x? Okay.
Yes.
Equals, I got this on my calculator, 4.3923 something or other. Do you guys agree or not agree?
Yes.
Everybody agrees, because we did some calculator work last week, but I want to make sure we got people with me. Okay. Everybody's okay with that. ln of 21 divided by the ln of 2 became this 4.3 something. Okay. Hang on. For all I care, you could write 4.3 on the board, on your paper. It doesn't matter to me. But you're going to keep all the decimals on your calculator. Okay. The rest of your work is going to be done on this calculator. How would you solve this problem? What would you do to this problem?
Add 1 divided by 5.
Add 1 divided by 5. We'll do it on your calculator. What I'm doing is saying you don't have to write down all the stinking decimals. So you're going to add 1 to my calculator, add 1, enter, divide by 5, enter, and I get x is, okay, x is, I get 1.078463 and so on. And then the instructions will tell you what to round to. So at this point, once we say you're going to use your calculator, then you don't have to show me any steps at all. You can do all the rest of your work on your calculator. So the real algebra here is, if they're not the same base, what I do is I take the ln of both sides. Why? Because that allows me to use my log laws, and most importantly, that allows me to bring the 5x plus 1 down out of the way. Then I divide both sides by the ln of 2. And at that point, I quit and go, I'm going to my calculator. Everything else is going to be done on my calculator. The ln of 21 over 2 is 4.3 something. Add 1, divide by 5, and then round according to whatever the directions say. Yes or no for everyone?
Yes.
Yes.
Any questions, any hesitation? Okay, now I'm leery of showing this to you. Okay, but I'll do it anyway, and then you can take your pick between this way and the second way I'm going to show you. And then we'll do one more, and then we'll call it for the night. Okay, same problem. 2 to the 5x minus 1 equals 21. Instead of taking the ln, okay, which is, by the way, what most of your science teachers will use, and most of your math teachers will use this technique. But you could also take the log base 2 of both sides. Okay. Took the log base 2. Well, then the question is why did I pull log base 2 out of thin air? Because that was the base 2 of your exponent. Watch what's going to happen. I took the log base 2 of both sides. I still bring the power down. 5x minus 1 times log base 2 of 2 equals log base 2 of 21. I apologize for squeezing it in there. Well, what happens to the log base 2 of 2? We've done that a bunch of times tonight. What's that turn into?
1.
1. So all of a sudden, this problem becomes 5x minus 1 times 1, which I don't need anymore, equals log base 2 of 21. Now, we did this on our calculators last week. Okay. Though if you have the TI-36X Pro, it has a special base 2 button if you push the log enough. If you don't have it, remember this could be written as the log of 21 over the log of 2. That was called the change of base formula. So this could be 5x minus 1 equals that mess. So finish off the problem either by using your magic button on your calculator, your base 2 whatever, or by calculating log of 21 divided by log of 2. I'm gonna do the second one just because it's harder. And if life is good, we got the same 4.3 blah, blah, blah. Did you guys get that?
Yep.
Okay.
Yes.
So what if this had been 7 to the 5x minus 1? What log base would you take on both sides?
7.
7, log base 7. So whatever the base of the exponent is, you take the log base of 7 to both sides or whatever it was. That's an acceptable one. I will tell you that about 80% of the world takes the ln of both sides and works it out this way. But there's another large chunk of the world that does it this way. They just use whatever the base was as a hint to finish this problem. All right, let's do one problem and then call it for the night. And before I put this problem up, am I understanding correctly that on Thursday, we're going to have one quiz that's going to be due Thursday night, a second quiz that will be timed, but due over the weekend, like due Monday night, but it will be a time. So once you start it, then you're stuck. You have to finish it. Is that what we kind of agreed on earlier?
Yes.
Yes.
Okay. All right. I just want to make sure that I've got that in my head right, and I'll fix that tonight. So here we go. I'm gonna make this a little bit more awkward. 5 times 7 to the 4x minus 6 equals 705. Now, wait a minute. Before you get started on this, you can't use any of your log laws until you get rid of the 5. You can't use any of the things we did over there until you somehow get rid of the 5. So what would you probably do to start this problem?
Divide.
Divide
Divide
both,
by 5.
yeah, divide both sides by 5. And so that would give you 7 to the 4x minus 6 equals, I don't know what that is. 141. Okay. So that's a hint. You have to isolate the same base, the base, before you start this process. Now I'm going to pause while you guys finish it off. Let's see. So I'm going to take the ln of both sides. So this is the ln of 7 to the 4x minus 6 equals the ln of 141. This allows me, because it's now a logarithm, I can bring the power out 4x minus 6 times the ln of 7 equals the ln of 141. Divide by the ln of 7, so 4x minus 6 equals the ln of 141 divided by the ln of 7. The rest of this is on my calculator. So just if you're keeping up, this is 4x minus 6 equals 2.54 something. Please understand that I'm not rounding to 2.54. I'm keeping all the decimals on my calculator. Okay, I'm going to do the rest of my work on my calculator. So I'm going to add 6 to both sides. We divide by 4. And I get x is 2.135789 and whatever, we haven't decided what to round to yet, but if you got that, you got it correct. And with that, thank you. It's been a longer night than usual, but we're done. See you tomorrow, guys. Bye. Unless people have questions, of course.
Thank you, Professor.
Okay.
Have a good night.